now I can get started. I'm going to write 2 words before I get started on this stuff here. 2 words for you. Start off with that way. I think I'll do it down here. Population statistic or statistics. There might be a capital word statement, statistics in general. You're taking a statistics class. Embedded in this course, you've got a lot of vocabulary, a lot. The back of the packet, I'll even flip over there right now for you. Way at the back of the packet. I'm flipping. There's a lot in here that I've given you. I've got what I defined as a definition sheet, and then there's symbols along the way that you'd fill in if you wanted to. By the way, the answers over here, the symbol is on the previous page, so it all matches up. Gives you practice. And definition over here, you'd fill that in by just over here. Anyway, I've got 41 altogether. When this was face-to-face, when it was face-to-face, the exams for the students would include symbols and definitions, no notes, no calculator. I required my students to memorize the symbols as well as the definitions. Well, we're not there, so you don't have to memorize them. You just have to know and be familiar with them. And I'll point them out when we get there. But there's a lot of words and phrases in here. You can see a lot of these things are not familiar. Like standard deviation, that's probably not familiar. The word null might not be. Confidence interval. In algebra, you had interval notation. The precursor to this course, prerequisite, let's call it, used to be called a prerequisite. You'd have interval notation, which had parentheses and brackets and comma in between. This right here would have a parenthesis, maybe a number, comma, maybe a bracket. You were introduced to that and worked a lot with it in a 155 type course. So we're going to see the notation, and then there's something that goes with what's called a confidence interval towards the end of the semester. So you got a lot of words, and so I'm throwing out 2 words to begin with, population versus statistics. Let's say it's the United States of America, and the census, whether or not they did it this year or completed it, I'm not sure. The census would indicate at that time how many people were alive in the United States of America as a population. Then if we looked at Sonoma County census, that would be a sample of the whole population. Samples are a subset. It's usually not the same as that, because then it would just be the population. If you went and wanted to ask, that's the big deal about a census. They're trying to get every 10 years, they're trying to get everybody to respond. That takes manpower, woman power. That takes people, money, energy, time. If we were trying to do just the Sonoma County, less time, less money, less people. So the smaller the sample, you're not spending so much time or money. But if you just took a sample of the 24 people or the 29 people right here, are you guys representative of Sonoma County? For whatever reason. Now, you don't know what that means yet, but representative of what? I don't know. Let's say I was pulling favorite color. Just make a silly question. If I asked you guys what's your favorite color, and I took a poll, and let's say it was red. I don't know. The favorite color was red. The most people said red. Do you think that is representative of everybody in Sonoma County? And so the question might be posed, and the answer might be, well, maybe, maybe not. There's only 29 of you, and what is 150,000 people in Sonoma County? So we're going to talk about sampling, how big a sample eventually is representative. But even so, a sample could have errors in it, a mistake. And how much of a mistake are you willing to accept? And we'll talk about that. It's called a margin of error. So statistics right now, usually we look at samples. This is like a sample. And today we'll say, how do we sample? You know, there are techniques, lots of techniques, and we're going to look at 5 of them today. You want it to be random. You don't want a bias. Most of you have probably heard on the radio or in the print about certain, let's say, marketing. Well, that's an easy thing, marketing. Long time ago, true story. The eggs got slammed. Eggs. Advertisement says eggs are bad for you. Cholesterol. Oh, too much cholesterol. And egg industry got slammed because people believed or thought it was true because of the advertising. And they say, well, why do they say that? Cholesterol. Well, we took a sample of, and that's where you look and say, well, they only sampled 100 people. And they're making the statement that their cholesterol is high just because of eggs. How do they know that? Well, later on, 10 years later, the article, not that article, but they came out and said, you know, eggs are a good source of protein. 1 egg a day, okay. Doesn't really affect your cholesterol. So salt, that's another thing. Long time ago, they said salt's bad for you. Well, later on, they found out, oh, actually, we all need a little salt in our diet. See, so you have to look at what's being posed and say, well, how many people did they survey? And statistically wise, it might be only 30. You might say 30 is good enough. Well, that seems like really small. So part of it might have to be, is it random? Like right now, if I asked 29 of you, you would be called my convenient sampling technique. And that is one way. And, you know, there's a variety of people of race and maybe religion and maybe gender. But the age, I don't know if I look at the age, you guys are fairly young, millennials, X-Geners. How about us baby boomers? I don't see anybody maybe here. We have an opinion. So it might not be a very good representation, depending on the question that are being asked, but you'll be called convenient. And there's 4 other sampling techniques we're going to look at. So population is everything. A sample or statistics is a subset. Now I'm going to write out 2 other words here. We're at the statement variable. Now in algebra, you had this thing that you were introduced to in the beginning algebra, the word variable. And our favorite letter of the alphabet in algebra probably was what letter? Probably. What do you remember? Your favorite letter?
N or X?
X.
Yeah, probably X. N might be there. X, Y, Z, A, B. Yeah, Y. I heard Y. Yeah, there's probably a lot of commonly used ones. And typically we use the letter of the alphabet. In trigonometry, some of you may have had that. We often honor or recognize the Greek symbols, call it, because they contributed a lot to mathematics, the Greeks did. So they use the Greek letters of the alphabet: theta, gamma, delta, chi, phi, phi, pho, phum. It sounds like a fraternity or sorority when you hear about it. And so instead of X, Y, Z's, they use theta, gamma, alpha, beta, things like that. So it's variables. Here, a variable can be what's called continuous or discrete. And as we go about our business today, and in your homework, you're going to be asked about, hey, do you think this variable is discrete or continuous? Here's the difference. Discrete is something countable. And continuous is something that you measure. Discrete, continuous. Continuous, here's an example of continuous. Many of us have gone to Costco, and you wait in line, and we're impatient, or anyway, time in line. Time is continuous because you measure the time in terms of what? Seconds, minutes, hours, nanoseconds, something you measure. Weight, how much we weigh, that's measurable. Hair growth, the length of your hair, it's measured. Temperature, you measure temperature. Those are all continuous variables. So discrete versus continuous. Discrete would be, all right, I watch, my youngest son loves European soccer. His favorite is Liverpool. Yay, they won the biggie this year, Liverpool. How many goals did Suman, I think his last name, first name, anyway, the big star for Liverpool, how many goals did he score on average per game? So you'd say, well, goals, every game is going to be a number. It's not like 2.5 or 2.3333. It's not. It's a number of goals. That's discrete. So the book's going to ask you whether you think it's continuous or discrete. Now, up here at the top, now, coming up here, I see some other words. So we got the word quantitative, and in there is a root word, quantity. So this is like a number, numerical in nature right here, like a number. Categorical or qualitative, they mean the same thing. Our textbook takes I think they take qualitative as the choice. Some authors and textbooks use the word categorical. So I will use both of these during the course of the semester. They mean the same thing. And think of this as like a category. Category. Something, a category. So I'm going to look at number 2 first. A person's height is a number. Now, if I wanted to think about a category, you might say short, tall. That's like a category. It's a word. But really, most of us are going to say it's a measurement. Oh, think about this as a measurement. That would be continuous. And then that would be quantitative. So I'm going to use Q-U-A-N-T. I'll use quantitative. I'm going to abbreviate Q-U-A-L and Q-U-A-N-T, just to abbreviate so I'm not writing so much. Okay, type of a student's textbook. Type like math, English. See, there's no number assigned to that. That's a category or a quality. So this would be like qualitative. Okay, number of calories a person brings in. Well, number, that's a giveaway. So, oh, brand of soda if you drink soda. If you don't, you're still going to talk about it. Brand, that's a quality. So Q-U-A-L, quality. Amount of memory left on a computer. Well, usually memory is measured in kilobytes, megabytes, terabytes. It's a number. So this would be quantity. Okay, now I go back to this one. Now, a lot of the females here probably have never gone and shopped for a guy's shirt. Size of a guy's shirt, it depends on what kind of shirt. So this is a little ambiguous. Sometimes shirts are measured by this one: small, medium, large, extra large, and so on. And if it's like this, it's a qualitative. If it's like this would be qualitative. But if you go into a very fine men's dress shop, clothes shop, and you're looking for a dress shirt that needs a tie, let's say, and it's long sleeve, they're going to measure it by neck size and sleeve length. So that's a number. So this could go either way. I'm not going to put either one because you have to ask the question, well, what are you talking about? Oh, but it does say t-shirt, my mistake. I think I changed it from last time. I think I put it as shirt before, men's shirt, and that's why I bring this up. Yeah, if it's a t-shirt, I don't think I've ever seen it as a neck size now. It's always small, medium, large, extra large. So then, because it's a t-shirt, then it's qualitative. So I do know qualitative. But if it said just shirt, that's a little ambiguous. Okay, a few more examples here. I'll use quantitative and C for categorical, which means the same as qualitative. Number of tickets. That sounds like a quantity. So Q for quantitative, Q. Amount of body fat, Q. Favorite baseball. Well, I don't know what the season looks like right now. It's looking pretty sad. Giants. Okay, well, that's the word. Giants. Go Giants. That's a categorical. C for categorical. So either C or Q. Okay, there's that time in line. That's a Q. Number of students enrolled in Santa Rosa. That's a Q. Brand of a toothpaste. That's a C. Age of executives. That would be a Q. Now, in red, what I'd like to do is red, I'm going to identify this grouping with continuous versus discrete. So in red, I'm going to put a C and a D next to each one of these. C and a D. Okay, number of tickets sold. Well, yeah, I don't have 2.5. Yeah, it's got to be this, discrete. It's a distinct number. So D for discrete, sorry. Okay, the amount of body fat. Now, one might argue and say, well, it's measured in grams. Oh, I just used the word measured, didn't I? Well, I would probably lean more towards the continuous, not the discrete. Because how do you measure it? Well, someone might say it's always kilograms or grams or something like that. So I'm leaning towards continuous on this one, though, more than the discrete. What about 3? What do you think? Or maybe it's neither.
Jeff, I'm not able to see what you're writing. The camera's on your face and not on your notes. It was when you first started writing.
Yes.
It was on the population versus statistics at the beginning, but then it's been on you after that.
Thank you for interrupting me, because sometimes I don't know what happens. I have to reshare this again. So thank you for not having me go much further than that. Let's see if I can bring this back up. How's that, Jan?
There we go.
Okay, now I'm going to flip back over. You've
Thank you.
verbalize it. Let me flip back over for a second. You guys see what I wrote. Yeah, until you guys tell me, because I saw it as perfectly fine with my computer. But yeah, thanks, Jan, for stopping that.
I saw it too, so I don't know happened to her screen.
You guys were okay? Emily, you're okay?
Yeah, I saw it the whole time.
Yeah, I was able to see it.
Okay, Jan, it sounds like it was yours. So look at the recording, okay? Jan, look at the recording later for this.
I think what might have happened was the view of what her screen was looking at changed, because you can change from speaker view to the screen share.
There you go. So Natalie's suggesting, Jan, that if you go in the upper right corner, if you do speaker share, or if you can pin me when I'm talking, you can I think it's double click on just me, and then it's just showing me the whole time, or showing this maybe. Okay, back to this with red. Yeah, guess what? Neither one of these works because this is based on quantitative only. Only because these are numbers. Only quantitative. Has nothing to do with categorical. So you can't identify this one. This one I can. That's C for continuous. Remember, this is red here. So not that C, that's blue. C for red. Can you see the difference between the colors? Maybe you can't. Okay, so I'm going to do this. Box this C, box this C, box this D. Okay, so everything I'm boxing has to do with these guys down here. That'll help. Number of students. Well, that's discrete because there's just, you count them. There's 155 students in my fall semester classes. So that would be, excuse me, D. Okay, categorical has nothing to do with these guys. Okay, and then the age, that's something you measure. What do you mean, Jeff? I'm only 18 years old. No, you're 18 years, 3 weeks, 2 days, 1 hour, 5 minutes, 2 seconds, 3 seconds, 4 seconds, 5 seconds. See how that's being measured. Now, age is an example of continuous. So I'd write C like this for continuous. All right, now, in my textbook in 1.2, when you go through 1.2 in your reading, certain things I'm not covering. You could ask me next week, says, hey, Jeff, I read about this census, something about census. You talked about it, but am I held responsible because there was no homework on census? And then I would say, no, you're not held responsible for that on an exam. But I would just suggest you do the reading anyway, because you've got time over the weekend. What is statistics? And they'll just talk about what you probably have a sense about that is. And then you'll see some blue boxes right here, what's maybe important to what's going on. So, yeah, some good reading in there. And then down here, you'll see words, keywords that say element, variable. Oh, I've used the word variable. Element, observation. Yeah, I didn't use those words so far. You can look at it. I don't think I still use them later on, but you can use them. So would I ask you for the definition of element and observation if I didn't use it? No, I wouldn't. But it's good to have that vocabulary there. Flipping around. Oh, right here. Didn't I do these guys? Just now. So then you can see what they're talking about here. Let's see. I'm not holding you responsible for number 4 here. You can see italicized. There's questions in your in the homework section, but I didn't give you any homework questions to know about any of that. So you're not held responsible for anything that I didn't give you as homework questions as well. These won't be in your homework that I assigned, not that. Giving you the word population. Parameters, yes, you need to know what a parameter is. Parameter goes with the population. See, parameter goes with the population. I used the word sample already, and I used the word statistics. So the P's go together. See the parameter and population? And samples and statistics go together. The S's go together. It's easy to remember. Oh, and then we're in homework. So that covers 1.2 right there. That's it. See, I told you it wasn't too bad. Yeah, Spencer.
I don't quite understand the 7th question, age of executives in Fortune 500 companies. So how would I be able to answer whether that's quantitative or discrete if I don't understand it?
Well,
Like what does that mean, I guess is what I'm asking.
mm-hmm.
This particular question.
Okay, Fortune 500 companies, if you've never heard of that,
No.
you might think Microsoft is probably a Fortune 500 company. If you Googled it, yeah, let me see, and I'll Google it right now. Or ask Siri. See, sometimes you can say, okay, well, Jeff didn't cover that. There are 500 top companies that are probably the top revenue, or well, let's see how they base their decision on the. Usually it was Forbes, Forbes. Forbes was the company that I remember, and they might even have a magazine that every year they honor the top 500 companies. But what's their conditions? I guess that's the thing. I'm not quite sure. I'm gonna go like this, go here. Can you see what I'm doing right here?
Yeah.
All right. I'm going to do a new. Can you see that right now? What I just did? Okay.
Mm-hmm.
FOR Fortune 500. Okay, let's see.
Yeah. Okay.
Oh, here. Let's see.
In other words, I could just search it if it were a homework assignment.
Yeah, the largest. Okay, so they say largest by what? Oh, by total revenue. Okay, so they kind of tell you what's happening right there. And let's see, rankings. What is this here? Curious. Oh, Walmart. Oop, I thought I saw Walmart. Top 10. Oh, looks like. I don't know if you can see that. Walmart, number 1. That's in terms of millions. 523 million. Million? No, I said it wrong. 5,000. Oh my gosh. 523,000 million. That's like billions, over
Yeah,
billions.
wouldn't that be billion?
Trillions, probably trillions. Yeah, some of these you don't even know. Oh, Volkswagen, look at that. That's interesting. They're up there. BP, I think that's British Petroleum. Amazon up there. So that gives you an idea of what that idea is. So in terms of our problem, really you're noticing it's called age. So the age of these executives. And that's what they want, or I want to know what the, is it discrete, continuous for the age? Is it quantitative or qualitative for the age? And I think you know it's a number now because it's an age. That makes sense, Spencer?
Yeah. Thank you.
Yeah. Thanks for asking the question.
I have a question before moving on.
Who is that? I'm looking to see who asked that question.
Anna Yelly.
Oh, there you go. You came up on my screen. Which number?
No, I just kind of have a question on discrete accountable. Like, I didn't really understand the sample you gave of like the goals, because I know measurable, it's like time, height, whatever. But the other one, I was wondering if you can maybe give like another example of what you mean by countable or discrete.
Can you see my page?
Yeah.
A finite means it stops. Finite or accountable. Okay, let's see what else they say here. Each value can be graphed as a separate point on a number line. Okay. The space between each, there's a space between each point. All right, so on a number line between number 1 and 2, in algebra, you might have talked about this, that there's infinitely many numbers on the number line between the number 1 and number 2. Infinitely. That's where this continuous would come into play. That's something you're measuring. If I just want to say, okay, the number of textbooks in your backpack. Let's say you had a backpack and you're bringing it. The number of textbooks that you have for your courses. How many do you have? How many courses do you have?
3.
Okay, I didn't even talk about the number of courses. Okay, you got 3 courses. Let's do courses. You have 3, Emily's got 4, Natalie's got 1. See, that's discrete because it's a specified type number.
Oh, okay, I think I understand now.
Yeah. How many siblings do you have?
2.
Oh, okay. Spencer, how many siblings do you have?
2.
Uzel, how many siblings do you have?
2.
Okay. See, so
What have we
you're
learned?
agreeing 2. Could it be that someone says none? So they're only child. Yeah. So again, that's an example of discrete. You're not saying I've infinitely many. You don't. Siblings, you don't. So I think once you start looking at some of the examples that they ask you about, you'll get it. You'll get the idea.
Okay, thank you.
Okay, now on to a section. I'm giving you 5. There's more than that in your textbook, but those 5 are in your textbook. And of the 5, there are 2 that are confusing. 3 are pretty clear. 2 are confusing. I'll show you the 2 that are confusing. These 2 right here. I'll put an asterisk right there. So I'll do those 2 last. Now, I've given you 5 examples and 5 definitions or sampling methods. There's only 1 for each, so everybody gets 1 for right now. As an example, your textbook does an excellent job on explaining the differences with examples too. And I'll probably go to the textbook and point out number 2, number 4, because they'll sound similar in the textbook, the explanation. But I'm going to focus on some key words for those 2. But if I look at, let's say convenience. Remember I said you as a class are my convenient sample just because you're nearby. If you're going to sample and ask, you have a survey, and you're going to ask some people a question in your stat class, couldn't you go to your family? You call them up and go to your family because you got their phone numbers or your friends, 5 friends. They're convenient. Go down your street, your neighborhood. It's convenient. So convenience, out of these, which one do you think is convenient?
B.
B.
Yeah, I would say B. Yeah, sure. Friends again. There are those friends. Okay, so I would put the number 1 right here. That goes with B. Yep, I do the same thing. All right, so we got a convenient thing thrown out. Okay, I'm going to do number 3 next, systematic. Now, systematic would be, as for instance, you go to, because I gave you a project, let's say, and you felt comfortable going out in public, even with a mask, and you got permission at the local Walmart. Let's say, since Walmart was fresh on our brain, a global 500. You go to Walmart, you go to the manager and say, you know, I've got a class at SRJC. I'd like to stand out in front, get your permission, and ask them some questions, survey. Would that be okay? And they say yes. So you got permission. So you got your clipboard and you have one question, one survey question. And what you'll do is you pre-decide who you're going to ask by the following. This way you don't have any bias. See, if you don't have a strategy, you'll have a bias. You might be drawn to people your own age, your own sex, the look, the clothing. You might say, oh boy, I'm not going to ask them. They look, yeah, you'll have a bias in there. So what you do is you say, before you go, I think I'll take every 10th person, T-E-N-T-H, that every 10th person that goes through, no matter what, I'm not looking at anything except counting. So you're standing out there and you're counting. People are either not making eye contact, so a lot of people don't want to, answer any questions, or so you're counting 1, 2, 3, 4. Finally, the 10th person comes across your pathway, and you say, "Hi, my name is Spencer Scruggs. I'm a student at SRJC," and they're standing there listening to you. They're giving you the time of day. Oh, okay, that's nice. And you say, I've got a project, and I just want to know if you've got time to answer one question, taking a survey. Well, sure, happy to help you. So then you are handing them the little survey sheet to have them check it off. In the meantime, a lot more people are coming into Walmart. You're ignoring them. And you say, thank you very much. And that person now goes into Walmart, and you start the count over again. Okay, another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hi, my name is Spencer. And they kind of say, nope, no, thank you. Don't do those things. Okay, fine, thank you very much. You take the next one. You keep taking them until you get someone to say, yes, thank you. And so you're asking that person, same question. In the meantime, people are coming in, leaving. So maybe you've got to do that for an hour. Let's say that's the requirement for me. Or maybe you do that until you've collected 100 responses, however long that takes. The idea of that technique is you're taking every nth, N-T-H, nth. So down here, I think you're looking at letter D, aren't you?
Yes.
Yeah, well, they use a radar gun to measure the speed of every 10th vehicle on the interstate. So instead of them saying, well, I'm going to target those red Camaros because they're red and I know they're going fast, they should be maybe doing random checks instead with the radar gun. Yeah, so I would say this one here is number 3. Okay, that scratches off 3 here. Okay, the next one is number 5. I'm just going to tell you which one it is and then explain, maybe it's self-explanatory. Letter A is number 5. And if you read what letter A is doing, it says, you're letting a computer randomly generate phone calls, like a robocall or something like that. Randomly call you. Polling. We're getting into this election year, and you're going to be bombarded by election day with polls, P-O-L-L-S, polls. I'm going to suggest that you look on your television screen or your, social media screen. If they're doing a good job, which the televisions do, the bottom corner, left or right, usually in very small print, will tell you how many people they polled. Instant poll. You probably have heard polling companies like Nielsen. Nielsen is a big company for polling, or ABC polling. They do their own polling. They might say 1,002 people. They did an instant 1,002 people. Well, that's their sample. Sample. They didn't poll everybody because I've never gotten a poll ever. What about my opinion? You might get offended. What about me? They're saying so many people are for candidate A, and not so many. They're saying 50% is for candidate A, and 42% is for candidate B. And what does that give you? 92%. And that means there's still a percentage undecided or whatever. Candidate C. Well, shoot, candidate A looks like they're winning. This is where the media sucks you in, because you think, well, my vote's not going to count because candidate A, they're saying candidate A is winning 50% away from 42%. That's too big a gap. No, they only asked 1,002 people. Where the heck did they ask? I don't know. So, and if on the bottom right corner, here, I'll even show you. I think I even got a picture of this while I'm talking about this. And I'll come back to it again when we get into the end of the semester. Yep, here it is right here. I stopped my television. I paused it one time because see, this is CBS, Good Morning CBS on Sundays, and they were throwing this up here. Support. I don't know what it was supporting, something to do with traffic or something like that. Cones. 88% of the people support something. That means 12% of the people don't support it. How many people did they poll? It doesn't say. But over here, that's going to be a key thing for you in this course, because it says margin of error. And it says plus or minus 2.7 percentage points. That means they could be off. They could be mistaken by that many. This percent could be as high for support as, let's say it's 3, as a 91%, or it could be as low as 85%. And that's where the confidence interval, or the interval, parentheses, between 85 and 91. That's where probably the real answer is. So they took, I don't know, 100 people, and they came up with 88 said, yes, support. 12 people said, no, don't support. But that was just 100 people, and they probably are wrong. I'm hearing on the news today about this whole COVID and the test thing that maybe it's not reliable. The testing companies are not reliable. Oh, great. They're getting false negatives and false positives. All the numbers that you're hearing could all be like, oh, they're all screwed up. You know what a false negative is? I'm going to tell you right now, because we're going to talk about this in this course. They test you, the results come back negative, but really you're positive. That's a false negative. It says you're negative, but you're really not. Okay, here's the other one. It says you're positive. Oh, crap, what? Okay. Oh, later on they find out, no, the test was either tampered with or the testing was wrong. And really, you're negative. I use an example of this later on in the course. You go to the doctor's office and you have a test, or you're not feeling good or whatever. You just got to have a checkup. And the doctor says, okay, we're going to run a test. And they come back and says, oh gosh, Jeff, I'm sorry to tell you, but you got cancer. What? Are you oh my gosh. Yeah, you better get your things in line. Sorry to tell you that. Oh my gosh, that's awful news. So you go home, and an hour later, the nurse calls back up and says, you know, we screwed up. Sorry, you're fine. You just got the common cold. Okay, that's like a false positive. That was that's a mistake. That's an error. We'll talk about the type of errors that you can make. You don't want to make errors, but sometimes you can't help it. You can't be 100% positive, 100% absolutely in any testing certain. In this course, statistics, It's not about like algebra where you get an answer. It says x equals 5. I wonder if that's the right answer. And you plug it back into the equation. Hey, it works. Must be the right answer. That's not happening in statistics. It's approximate. It's around. It's an estimate. We want to be as close as possible. Yeah, statistics is not. So just understand that it's going to be a different kind of math class. Okay, here's the other scenario. I go to the doctor's office and I'm going, I'm not feeling so good. Oh, we better run some tests on you. Okay, they come back to us. You're fine. You're fine. Yeah, just take some orange juice and go home, take some aspirin. You're fine. A month later, you're still going, not feeling really good. You go back to the same doctor and they go back to us. Oh gosh, I'm sorry. We're looking at your past tests. We're looking at what you are right now. Sorry, we didn't catch this, but you have stage 5 cancer. If we only told you a month ago, we could have saved you, but sorry. Which news is worse? We'll talk about that in this course, but in your opinion, if I had a polling device, which I think there is, one of those pieces of information is worse, and we can debate which one is worse. Mathematically, one's worse than the other, but I don't know. I think the second one's worse. You were saying you're fine, but they really screwed up the thing, and had they told you, you could have gotten healed, but now, sorry, your days are numbered. That's worse to me. That's like a false negative in that way. Versus being told that you have cancer and get your life in order, and then you're telling you're upset and you're stressed and you're sick and to your stomach. But even a month later, you say, I don't know, sorry, you're fine. Forgot to tell you. So with all this said, you can't be exact. The polling, you look and say, how many people did they ask? Like here, here they said 1,000. All right, well, that's more than 100, more than 30. We got 300 million people. Not all of them are adults, and not all of them have medical conditions. All right, so now we're down to, what is it, C and E? C and E. Now, I'm going to go into my book and look under the definitions for stratified and then the one for cluster. I'm going to look up their overview first, and then they've got individual definition. Okay, so I'm not going to look at that right there. Throwing you off. Okay, are sometimes confused. Yes, they are. Okay, so stratified, you divide the population into subgroups. And then you take a random sample out of each subgroup. Oh, okay, let's see if I can do this. S for stratified, and this one here will be cluster, C for cluster. All right, so here's the whole population. In the box is everybody in the whole population. So it says stratified, we divide the population into subgroups. Okay, let's do 5 subgroups. Okay, there's 1, there's 2, there's 3, let's go 4, 5. 1, 2, 3, 4, 5. You divide it into 5 subgroups. And then you're going to randomly sample from each subgroup. Oh, okay, so let's say I pick 5 from here, 10 from here, 9 from here, 1 from there, and 7 from there. Every subgroup gets something. Versus cluster, you divide the population into subgroups again. Oh, okay, fine. Oh, so you go like this. Oh, let's do 5 subgroups. It doesn't matter what they look like. 1, 2, 3, 4, 5. and you choose everybody, all in selected clusters. Oh, okay. So you got to select how many clusters you want to look at. Well, you don't want to select all the clusters because that's like the whole population. You don't have time, energy, and money. So let's say, well, all right, let's do two clusters. Well, which two? Well, I don't know. Let's roll the dice. So you got a die, right? What is that? 6 sides? 6 sides? Okay, let's say you roll a dice and it comes up. Okay, this is die 1, 2, 3, 4, 5. You roll the die and it comes out the number 2. Okay, so I'm going to put an asterisk because it came out the number 2 there. So I'm going to focus on that. And I roll the dice again. It comes up the number 6. Yeah, there's no 6 cluster. Okay, roll again, and it comes up the number 4. Okay, 1, 2, 3, 4. So these 2 clusters are what you're focusing on. And the key phrase here is you're going to choose all right there. See that right there? So everybody over here gets asked, and everybody over here gets asked, and you ignore the other 3. That's called cluster. Well, I'm not going to look at their definitions because I think I did a pretty good job. I know I did. It's new for you, so you're still maybe confused. But I'm going to try to see if this makes sense. Maybe what I'll do is do E first. And the question is this cluster or is it cluster? Does it feel like this one or does it feel like this one? 25 students are randomly selected from each grade level at a high school. Okay, there's 4 grade levels. Let's assume that 9th through 12th grade, freshman through senior. So you've got, this is like here's my whole population. Here's the 4 grade levels, and it says 25 are selected from each. So 25 here, 25 here, 25 here, 25 here. Okay, which one does this one emulate? This one or that one? What do you think?
Stratified?
That's what I would guess, and that's exactly the right answer. Yep. This is number what, 2? Yep. Okay, versus, now why is this one cluster? All right, let's see. A pregnancy study in Cebu, Philippines randomly selected 33 communities from the metropolitan area, then interviewed all, okay, that's a key word, available pregnant women in these communities. Okay, so here's the metropolitan area. That's the entire population. Okay, 33 communities. Did they say there were 33 communities altogether, like in the entire metropolitan? They selected 33. So there were more than 33 in here. I'm not going to break that up. And then they went to those 33 they randomly selected and picked them all. So it's like this. This is only 5, but think of this as like there's 100 communities, and these were 2 of the 33. But you picked them all, picked everybody in those. That's why this one has to be the last one, which is cluster number 4. So in general, cluster and stratified are the confusing ones. And yes, on the exam, I will be having questions. And guess what? I'll probably have one, a question that sees if you understand the difference with an example between cluster and stratified, for sure. It'll be there. The textbook doesn't give you a lot of practice problems, unfortunately. That's why I think it was 23 through 36, the homework. There's only 5 problems, so 1 for each. Over here, I'm giving you 4 more examples here. And you probably could Google, I'm sure you can, YouTube, the concept of statistics, cluster versus stratified, and see what some other people in their videos say. I know you can do that and see some other examples. But you only have 5 homework problems, and all you're going to do is give words. So there's no process to do. There's no supporting work. Which brings me to homework. Jeff, how much work are you supposed to write out to support the answer? In 1.3, there is no supporting work. It's just the answer. And you don't have to write down the original question. Don't have to do that. But going forward into chapter 3 especially, there's a lot of work that, there can be a lot of work that you would need to do on your homework pages to support the, say, the number, the one little number answer that you get. I've got to see, I don't want your homework just to be an answer page. I don't want that. So give me something to consider for grading. Otherwise, I'll kick it back at you and say, no score right now until you give me some supporting work. Otherwise, it's your throwaway. You get 1 to throw away.
You're talking about all the other assignments, not 1.3, right?
Yeah, 1.3 just has words. Here, I'll show you. 1.3, 23 through 36, if I'm not mistaken. Now, some of them, if they say, hey, true or false, it'll say true or false. False. That's all they're asking, false. I'm not asking necessarily for a justification. But on 1.3, okay, which type of sampling? Just give me a word. Stratified or cluster or random sample or something like that. Just words. There's no justification.
Stratified.
Could be. Looks like the one I gave you, didn't it? Yep, that would be it. Yep. And then one more, and I'll let you do the other ones. What do you think number 24 is going to be? That's a key thing right there. Even if you didn't read the whole thing, what are they talking about? An instructor in a large lecture room of 300 people wants to get a student sample, so he selects every 10th name from the class roster.
Systematic.
Exactly. See, you got the first 2 down. There you go. Just the words. So your page for your homework for 1.3, remember you got a heading for 1.3. Remember that, your heading for your homework? You're gonna go math 15, and then you're gonna go section 1.3, and then you're gonna go your name and roll number now, and you're gonna have problems 23, 24, 25, 26 with just a word. And that's it on that page. Don't start 2.1 for me. Don't start it on or continue it on that page. I want it to start on a separate page. I'll say it again. Every section, 1.2, starts with its own separate page. If you need more pages to continue and wrap it up, great. But when you start the next section, start it on its own separate page. That'll help me see it better when you send it to me. If that's not clear, see me after class and I'll give you some examples. Okay, let's see what some of the chat room stuff is going on here. Can I get a screenshot of the homework? Okay, good. Yep, good. Yep, good. You guys are helping each other. Fantastic. Thank you. Right on. Right on. That's good. I'm done. I'm done. That's all I have for you today. That's those 2 sections.
Can I talk to you afterwards?
Absolutely. I will stick around for anybody, for any questions. I still got, what, 40 minutes before